all, thanks for watching our video talk. Our talk is about the team-up decision for crowdsourcing contest, focusing on whether individuals should work as a team or a solo endeavor. I am Keman Huang, an associate professor from the University of China and a research affiliate from MIT Sloan. Our study is motivated by two important observations regarding crowdsourcing over years. First, as many studies already reveal, the crowdsourcing is becoming a long-term career option for many crowd workers, meaning they are no longer short-term micro workers but professional freelancers who will rely on crowdsourcing tasks, including joint contests as part of their career. Second, in the crowdsourcing environment, they need to work together to solve more complex tasks. However, when working together as a team, they are not a team like the traditional team, which have many processes and social relations embedded in their working environments. Instead, they are more like an on-demand transient team. While many studies have investigated these two trends in crowdsourcing, how does the freelancer collaborate as a transient team is not clear yet. Therefore, our goal for this study is to unfold such a process by answering these four questions. Is working as a transient team become a trend? Whether it's always a good choice? Whether working as a transient team can be helpful? And finally, we would like to know what makes individuals to work as a transient team member. To answer these four questions, we use Kaggle as a case for our studies. This is because, first, Kaggle is one of the largest data science-oriented crowdsourcing contest platforms, which tasks are non-trivial in nature. It provides a rich set of data, including contest, team, individual, and submissions that we can leverage for our study. More importantly, its team system around individuals to work as a team or as a single workers, rather than force individuals to form a multi-member team, which match our research scenarios. Finally, it also provides a system that tracks individuals' growth as a data scientist over years, including their productivity, point, and methods for each contest, enable us to understand the long-term growth from multi-aspects. Therefore, Kaggle meets perfectly to our study. In fact, Kaggle has become the de facto standard for data science-oriented crowdsourcing platforms, also making our conclusion more generalized. So, using the dataset from Kaggle, we start to focus on the first questions. Due to the time limitation, I will just discuss our conclusion here, while all the detail for the calculation can be found in our papers. First, as we can see in this figure, it's very clear that working as a team is increasingly become the trend in Kaggle. So we further dig the test, and we can see a significant p-value here, meaning there is a significance between year differences. Therefore, we further investigate what factors in the context level can impact the team-up ratio. As we can see here, a shorter context length, larger data size, without kernel submission requirements can increase the team ratio, as this context factor generally indicates a more complex context. The negative effect from reward side, meaning more rewards, will reduce the team ratio as individuals may think it becomes easier to get the rewards, so that the competition for the contest is not that intensive. Second, since team up is indeed the trend, we are interested in whether working as a team is always a good choice. As we can see here, working as a team can get more medals, higher productivity, but will get less points from Kaggle. One reason is that Kaggle actually punishes the teamwork when calculating the point. Additionally, as the p-value shown here, there is a significant between year differences. Therefore, we further look into what factors impact such a gap. From this result, we can see a significant negative effect on the medal gap, meaning the benefit for medal is decreasing while the benefit for productivity is increasing. One interesting here is that the adoption of Kaggle kernel actually is significant positive for medal gap, meaning working as a team can benefit more from kernel adoption. Third, since working as a team is not always a good choice, we would like to know whether the experiment of working as a team can be helpful for individual short-term and long-term performance. First, as we can see here, for the short term, it means whether an individual can get better performance in a given contest. You can see that they are both positive relations here. Therefore, previous working as a team, their experience can be helpful for an individual to gain a better performance in a short-term context. From the long-term aspect, it means whether an individual can get better cumulative performance over time. Again, we can see the significant positive relation here. Therefore, more teamwork experiment mean better long-term performance. Therefore, the teamwork experiment can be helpful for individuals short-term and long-term success. Finally, given all the observation above, now we would like to know what motivates individuals to work as a team. From the results shown here, we can see the negative relations for solo-related intellectual capital and positive relations of team-related capital both significantly. This indicates a past dependency effect for working as the team member. Then we test the moderating effect from the pre-out collaboration tiers. We can see a negative moderated effect for solo-related IT and positive effect for team-related IT. As we demonstrated in the diagram here, it means that the effects amplified by the pre-out collaboration tiers. This means that for individuals who have a strong solo-related IC and a larger collaboration tiers, they have a good performance for working thoroughly and not so good teamwork experiment. Therefore, the positive for them to team up will be low. This indicates the reinforced effect of the past dependency effect for team up strategy. So, based on what we observe, we put all these answers together. Now, we're able to unfold the team up process in the Kaggle case. We can see that, indeed, working as a team is the trend, but it's not always better for all matches. And the benefit in gaining more medal actually is decreasing. Working as a team in general could be good for an individual to gain the short-term and long-term benefit. There is a significant reinforced past dependency, which is mediated by the teamwork experiment when considering to work as a team or not. Based on the observation we get here, we can draw several design strategies for both individual and operators. For individual, obviously, teamwork could be helpful for them, so they are encouraged for teaming up, especially in the early stage. But since the teamwork experiment is important and could have the past dependency effect, the platform should pay attention to support the teamwork collaboration and improve the experiments, and help the individual to find the right team member for collaboration. Most especially, for a platform like Kaggle's, improving the kernel system for team collaboration can be helpful, and updating the point system to avoid too much punishment for teamwork should also be considered. Based on what we observe here, we'll say that considering the limitation for this study, we start further research to generalize our observation to other platforms, especially in other domains rather than data science like Kaggle, design experiment to record and investigate the team-up strategy and behavior, and finally, try to develop algorithms to support team-up process like how to identify the right team members. This is all for our studies. Thanks for listening and looking forward for your questions and comments. Please do email us if you are interested in these related topics.